Hello everyone, my name is Wei Cao. Today I will present our work, Parameter Efficient Semantic Augmentation for Enhancing Open Vocabulary Object Detection. Open vocabulary object detection models usually perform well on general domain datasets, such as OVCOCO. However, when they are directly transferred to vertical domains, such as insect detection, remote sensing, or underwater object detection, their zero-shot performance often drops significantly. A straightforward solution is fine-tuning, but fine-tuning can easily damage the generalization ability of the pre-trained model and lead to performance degradation on general domain data. Therefore, the key question we focus on is how can we improve domain adaptation while preserving the open vocabulary generalization ability of the pre-trained detector. To address this problem, we propose HSA-DINO, a parameter-efficient semantic augmentation framework built upon OV-DINO. In our framework, most pre-trained parameters are frozen, and LoRa modules are inserted into the image encoder to learn hierarchical and domain-specific visual features. This design reduces the number of trainable parameters and help avoid over-updating the original model. Our method contains two main components. The first component is a multi-scale prompt bank. Previous methods usually rely on predefined templates or learnable prompt vectors placed before category label embeddings. However, this method often ignores fine-grained semantic information from image features. In contrast, our method uses multi-scale image features to select relevant prompts. High-level features usually capture the overall object structure, while low-level features contain texture and local details. By retrieving prompts from different feature scales and concatenating them with category labels, we obtain prompt-enhanced text representations. In this way, the text features are no longer based on category names, but are also enriched by hierarchical visual semantics. The second component is the semantic-aware router. Some existing dynamic routing methods use reconstruction error from autoencoders to identify the input domain. However, reconstruction error from different domains may overlap, which can confuse the model and lead to incorrect routing decisions. To solve this issue, our router models both domain information and content information. This reduces the overlap between different data distributions and enable more accurate prompt or parameter selection. For optimization, our method is based on the original OV-DINO detection objective. In addition, we introduce two auxiliary losses for training the multi-scale prompt bank. The first one is the matching loss, which encourages the selected keys to be closer to the corresponding multi-scale image features. This helps the key learn domain-specific knowledge from image samples. The second one is the orthogonal loss, which encourages different prompts to be semantically diverse and prevent them from collapsing into similar representation. Experimental results show that HSA-DINO achieved superior performance on multiple vertical domain datasets. More importantly, it also maintains strong general domain open vocabulary detection ability. This demonstrates that our method achieves a better trade-off between downstream domain adaptation and open vocabulary generalization. Ablation studies further verify the effectiveness of both the multi-scale prompt bank and the semantic-aware router. To summarize, our contributions are fourfold. First, we propose HSA-DINO, a parameter-efficient semantic augmentation framework for open vocabulary object detection. Second, we design a multi-scale prompt bank that learns textual prompt from hierarchical image semantics. Third, We introduce a semantic-aware router to improve routing accuracy by considering both domain and content information. Finally, extensive experience shows that our method improves vertical domain performance while preserving the generalization ability of the pre-trained OVOD model. Thanks for your listening.